You know this silhouette. It's one of the most recognizable skylines in the entire world. You've got these three massive towers leaning into each other with a structure that's actually longer than an aircraft carrier just balanced on top. It's Marina Bay Sands, a true marvel of modern engineering that looks like it's completely defying gravity. So, the big question is, how did they pull it off? In this explainer, we're going to break down the absolutely incredible engineering that made this icon a reality.
And, this wasn't just what the public thought. When the design was first shown to the world, engineering experts, the people who actually build this stuff, they called it an unrealistic illusion. They were basically convinced it simply could not be built.
So, why even attempt something so audacious? Well, it all boiled down to a really bold plan. Singapore wanted to transform its Marina Bay into a global destination, a hub for tourism and finance that could go head-to-head with giants like Macau and Las Vegas. They didn't just need another building, they needed a statement.
But there was a colossal problem right from the get-go. The entire site, it wasn't solid ground. It was reclaimed land, which is basically soft marine clay. It has almost zero load-bearing capacity. To put it bluntly, it was literally the worst possible place to try and build a skyscraper, let alone 3 of them.
Okay, so you have this really unstable ground. But then, the design itself threw another huge challenge into the mix. And that brings us to the first great engineering puzzle. How do you tame that soft ground while building these iconic leaning towers?
So here's the core issue. A typical skyscraper is pretty straightforward. It pushes all its weight straight down into its foundation, which makes it inherently stable. But the towers of Marina Bay Sands, which were inspired by a deck of cards, they're asymmetrical. They lean, and this creates what engineers call eccentric bending moments, which is a fancy way of saying the towers are in a constant state of trying to tip over.
Which brings us to the million-dollar question, right? How on earth do you build these leaning towers on what's essentially mud and, prevent a catastrophic collapse?
The solution was this ingenious 4-part strategy. First, to deal with the soft ground, they drilled these super deep foundations that bypass the mud completely, anchoring the towers in stable soil far, far below. But that only solved the ground problem. As the leaning towers started to rise, they were temporarily held apart by a huge system of steel gracing. At the same time, they used pre-stressing cables to actively pull the towers inward, fighting that natural tendency to lean out. And then, the masterstroke. At the 23rd floor, the 2 leaning halves of each tower were permanently fused together with these massive link beams, turning 2 unstable structures into one incredibly strong, unified tower.
And the scale of that foundation work is just staggering. To anchor the whole complex, crews installed over 5,000 of these large-diameter board piles deep into the earth. It was one of the largest foundation projects in Singapore's entire history.
So, with the towers stabilized, it was time for the most dramatic part of the entire construction, lifting the sky park. And listen, this wasn't just about adding a roof. This was like hoisting an entire aircraft carrier 200 meters up into the air.
And to put that into perspective for you, the Sky Park is 340 meters long. That's longer than the Eiffel Tower is tall, and just about the same length as a modern aircraft carrier. It's an unbelievable size for something that has to be assembled 55 stories up. And it's not just long, it is incredibly heavy. The total weight of the structural steel in the Sky Park comes in at around 10,000 tons. You can't just use a normal crane for a job like that. No. Lifting that much weight required a super specialized technology called strand jacking. It's basically a super-powered hydraulic pulley system. It uses bundles of steel cables to slowly and precisely hoist these massive segments into place. This is a technique that's normally used for building huge bridges, not skyscrapers.
And the precision required for this operation, it was just insane. These teams were lifting segments weighing up to 1,400 tons, and the process took hours. They used real-time GPS and laser guidance to maintain an alignment accuracy of just 0.5 millimeter, all while battling winds at high altitude. There was absolutely zero room for error.
So, the Sky Park is in place, but the engineering marvels don't stop there. Now we have to look at its crown jewel, that incredible, world-famous infinity pool. The first puzzle is the observation deck at the northern end. It's a massive cantilever, which means it juts out 67 meters from the edge of the tower with absolutely no support columns underneath it. It floats.
So how does it stay up? Well, the solution is a classic feat of physics, a lever balance system.
To counteract all that weight hanging off the edge, massive counterweights, we're talking hundreds of tons, are built deep inside the sky park, acting like the other side of a seesaw and keeping the entire structure perfectly balanced.
But stabilizing that cantilever, that was only one part of the puzzle. See, all skyscrapers are designed to sway in the wind, sometimes by as much as half a meter. This created a whole new problem. How do you keep a 150-meter long pool perfectly level and stop millions of liters of water from sloshing right over the side?
The solution is this incredible active stabilization system. Underneath the main pool, there's a network of over 500 hydraulic jacks that are constantly making these tiny micro-adjustments to counteract the building's sway. For smaller movements, a 5-ton tuned mass damper absorbs micro-vibrations. And finally, a massive pumping system is always circulating the water, catching any that goes over that infinity edge and pumping it right back up, ensuring the pool's surface stays perfectly still 57 stories in the air.
After more than a decade as a global icon, you'd think the story ends there, right? But nope. Marina Bay Sands is embarking on a new phase, a brand new architectural gamble that might be even more ambitious than the original.
A new fourth tower is planned, but it's not a simple copy. The design is even more complex, with this twisting, leaning form. It's going to be topped by a 2-level sky park, and its main feature won't be a pool, but a massive 15,000-seat arena. And the price tag? The price tag for this expansion alone is nearly $8 billion, way more than the cost of the original 3 towers combined.
This leaves us with a fascinating question for the future. The original Marina Bay Sands proved that the most unrealistic illusions can absolutely become reality. But will this new, twisting fourth tower be another masterpiece that enhances the skyline, or will its bold asymmetry kind of disrupt the iconic balanced silhouette of the original? I guess only time will tell.